Hello, everyone. I'm really excited to be here. Thanks for coming. I'm going to talk today about trends in web security, looking into Microsoft's cloud bug bounty programs. I'm a little embarrassed. I did not prepare a musical number like Doug did, so I'm sorry. So just a little bit of an intro. I'm a security researcher with the Vulnerability and Mitigations team at the Microsoft Security Response Center at MSRC. But I'm familiar with Utah. I did my bachelor's and master's in computer science here at BYU in Provo. My research was focused mostly on usable security, specifically the usability of different two-factor authentication methods. Then I moved to Washington a few years after I graduated with Microsoft, but I'm back. I actually moved back to Provo just this summer, so it's nice to be back in Utah. My fiance is an English teacher at Provo High now, so we love being in Utah County. I love board games, getting outside, running. I'm not a great cook, but I'm trying to be. So just to start off, who's this talk for? Of course, all of you who attended, thanks for coming. But specifically, I hope that this talk will be helpful for people who are new to security or curious about bug bounties and web vulnerabilities. That's the place that I was while I was at university. So I knew even before I started university that I wanted to be in security. But I didn't know what that path would look like. I took as many security classes as I could, but beyond that, I didn't really know where I would go. I was curious about bug bounties. I didn't know what those looked like. So I've tried to make this talk with my past self in mind. I've tried to make it pretty high level and accessible. So if you're also new to the security space and interested in web vulnerabilities, I hope this will be a helpful starting place for you. So first, I'll talk a little bit about Microsoft's bounty programs. Then I'll go over the most common web vulnerabilities that we've seen over the last year. Then I'll talk about what do we do when we see all these vulnerabilities, how do we mitigate those, and I'll end with learning resources, some of my favorite resources. So at Microsoft, we have kind of a dual approach to security. So internal security is really important. We have over 8,500 security professionals doing a variety of things to secure Microsoft. So of course, we have a lot of red and blue teams working to see if we can find vulnerabilities so that we can fix those. Earlier this year, I participated in an internal red teaming exercise, which was really a lot of fun. This picture that you see here is from our Cyber Defense Operations Center, the CDOC, which is basically where everybody comes together when there's a security event. So Microsoft has a ton of different products, and so when a security event impacts a lot of people across a lot of groups, the CDOC is where everybody can come together, work together. We can get all the experts in one room to handle the event. And also important is external collaboration. Let me see if I can. So we really love partnering with independent security researchers and security industry partners from around the world. And we do that through our bug bounty program to help incentivize researchers to report high-impact security vulnerabilities to us. Microsoft runs one of the largest bug bounty programs in the world. We love all the researchers who work with us. So in fact, one of my coworkers was a top researcher and now works with us. So he's moved from the external world to the internal world. If any of you have reported a vulnerability through us, a big thanks for partnering with us. So here's our year in review. At Microsoft, we go by the fiscal year, which for us starts in July and goes through June. So from July 2021 to June 2022, we issued $13.7 million in bounty rewards. That's across 17 bounty programs with over 1,000 eligible vulnerability reports and 335 researchers from over 45 countries. So it's quite a diversity of researchers, a lot of different programs. Of those 17 programs, we divide them into two main groups. So we have platform programs, which includes products like Windows, Microsoft Defender, Microsoft Edge, Hyper-V, even products like Election Guard, which is an open source SDK that election system vendors can use to make voting more transparent and accessible. And then we have, on the other side, our cloud bounty programs, anything that's cloud-based. So we have Azure, Azure DevOps, Office 365, Xbox Live. And that's where I work, is in the cloud bounty space, so that's what this presentation is going to be focusing on. And these slides are going crazy. Okay. I asked the bounty team to share some data with me about what growth in the cloud bounty space has looked like over the last few years, and this is what they gave me, so thanks a lot, bounty team. But it is actually kind of accurate. So they also shared some real stats with me. So over the last about 3 years, we've seen a 92% increase in researcher participation, about 140% increase in cases submitted through our program, and about a 500% increase in bounty awards annually. We've also launched, a lot of those bounty programs have been, of the 17 were launched in the last 3 years, including Identity, Azure, Dynamics, DevOps. So the point of all this is there's really a lot happening in the bounty space. Through these bounty programs, we get a lot of really great data, a lot of insight through our researchers into what are some of the most common vulnerabilities we see. And so here are the top 5. These are the top 5 over the last year issues that we saw through our cloud bounty programs. I'll note the top issues do vary a little bit year to year. So for example, SQL injection actually isn't a vulnerability we see very often, but it happened to be there this year because there was one security researcher who found one product with a lot of bugs there. So it actually made the top 5. If you look in percentages, XSS is a really big portion of those, and then the rest, it's something like just over 25%. The rest are like 4 to 7%, and then there's a very long tail because there's really a lot of vulnerabilities that we see. Like I mentioned, Microsoft really, there's a whole lot of bounty programs, a whole lot of products, so it's very broad. And this, of course, is just a piece of the overall trend picture, but it does map with what a lot of other industry is seen elsewhere in the industry, so it does map with broader trends like the OWASP top 10, which we have injection vulnerabilities, broken access control, security misconfiguration. That's also what we're seeing in our bounty programs. One thing I'll note, most common definitely does not mean most severe. So to just demonstrate that, I compared 2 different vulnerabilities here. So we have cross-site scripting XSS or server-side request forgery, SSRF. So the first row here, percent that meet our MSRC bar, what does that mean? We give security vulnerabilities ratings if it's a critical or important severity, or maybe it's a low or moderate issue. And that basically just helps us decide what issues to prioritize. So any issue that impacts customers or that can be exploited needs to be fixed with priority. That'll meet our MSRC bar for servicing. Cases that are only potential issues or more of defense in depth things that don't have a present risk, those we still want to address those, but they don't need the same urgency. So of XSS cases, about 39% meet our bar for servicing, compared with about 29% of SSRF cases. And then if you look at all the cases that meet our MSRC bar, about 29% of those are XSS, and only about 1% is SSRF. But of our critical cases, XSS is just 1%, while about half of the SSRF cases that meet our bar are critical. So that just goes to show, issues that are very common might not always be the most impactful, and issues that are less common are still really, really important to address. So like I mentioned, at MSRC, we see this constant stream of vulnerability reports. It's a really incredible source of data, and we want to fix every report that we get individually. But in addition to that, sometimes we'll notice patterns. If we see a product with a lot of a certain type of vulnerability, in addition to fixing those individually, we ask ourselves, is there a way that we can mitigate this entire pattern of issues or class of issues so that we can fix it at a higher level? And there are 2 kind of main ways that we think about this. So a lot of times in 4A here, there's something that already exists that works really well to mitigate issues. Other times, if there's something that's not quite what we need, there's nothing existing, then we'll see if there's something we can come up with that's a little bit new that we can use to mitigate issues. And whatever thing we choose to do, afterwards we can use that MSRC case data, the reports, vulnerability reports that we see, to monitor and see if the mitigation was successful or not. So I'm going to go through just 2 examples of things we've done, noticed a pattern, and then used some sort of mitigation to address it at a higher level. Like I mentioned, improper access control and cross-site scripting, they're 2 of the most common vulnerabilities that we saw over the last year. And so I'm going to talk about a service where we saw a lot of XSS issues, what we did, and then there was an API where we saw improper access control issues and what we did there. So before discussing the first issue, I just want to give a little overview about what XSS is. So I really love this image from PortSwigger, which shows an attacker who steals sensitive data from a victim through a cross-site scripting bug. So in the image, you see a script pointing to eviluser.net at the top, which a victim user, when they click this link, that the script from eviluser.net loads into this website that the victim user trusts. And so then the attacker is able to run arbitrary code on this website, steal sensitive information from the victim, whether it's passwords or mother's maiden name, whatever it might be. And we had a website where we were seeing dozens of XSS issues, and we wanted not only to fix those individual issues, but also see if there's something more we could do. And in this case, there's a really easy existing mitigation content security policy, which works really well to prevent XSS. So content security policy, or CSP, is a strong defense in depth mechanism that can make it very difficult or sometimes impossible to trigger XSS, even if you can find an injection vulnerability. And it works by allowing you to restrict how resources such as JavaScript, CSS, or basically anything that a browser loads, you can explicitly define where those resources are allowed to be loaded from. And it's typically done through an HTTP response header, although it also can be done through a meta tag. So this is a really simple example here. So on the right, you'll see there's a server with a content security policy header. In this case, it says, hey, the default source is example.com. So basically, by default, I only want to load resources if it's from example.com. And so how that works in practice, if you have on the left a victim user, say they request JavaScript from example.com that matches the policy, the browser will return it. Say they request CSS from example.com, that also matches. But if an attacker has been able to find an injection bug and is trying to get the victim to load JavaScript from malicious.com, since that doesn't match the content security policy, the browser will block that. So this is a pretty simple example of CSP, so this is a little bit more developed. So this policy example has 5 directives. Directives are what the CSP kind of rules are called. So the first one, like we saw in the last, default source, means unless I say otherwise, this is what you default to. So this is saying, by default, I don't trust anyone. Here, the second directive, script source, is set to a nonce. So in the previous policy, we used an allow list that said, hey, anything from example.com is good. That's good, but it's definitely not as strong as using a random nonce, because if an attacker can find another vulnerability in example.com, say, if they can find an open redirect or another XSS or something, they may be able to chain a vulnerability and still load malicious JavaScript through that allowed trusted domain. So nonce is a much more secure way to go. Script source is the most important directive for preventing XSS, because it tells the browser where JavaScript's allowed to load from. But there's really a lot that CSP can do beyond that. So here we have like image source. You can say, I will only load images from example.com. You can say, hey, CSS, I'm only going to load that from Self, my own website. You can also restrict things like where forms are allowed to be submitted. And there's a lot more you can do with CSP. It's a really, really great mitigation. And so we had this website where we had seen dozens of these XSS cases, and after we partnered with that engineering team who owned the site, then we haven't seen any successful XSS there. Even if somebody finds an injection point, they haven't been able to bypass the CSP. So that we consider that a success on our end. So the second kind of example I'll go through is an improper access control. So this is a fairly broad category of issues. And this is another great image from PortSwigger. Improper access control happens when there's information or functionality that isn't properly restricted to users with the right permissions. So in this image, you can see there's an admin portal. If a non-admin user can access an admin portal and do stuff, that's really bad. That's a big issue. On the other side, you see my account. If a user is able to access an account that isn't theirs and able to transfer money or do anything on that account, that's another really big issue. So we had an API where we were receiving some access control issues. We were seeing a lot of that in our case data. Here, I'm showing an example of an OpenAPI spec. OpenAPI is a standard way you can define RESTful APIs. It's both computer and human readable. It shows here like what servers are running the APIs and paths of different endpoints and what expected responses are. So you can see there's a user's endpoint here. So it's probably maybe any user is able to hit this endpoint and get a list of the other users. Maybe there's an admin endpoint here, which you shouldn't be able to hit unless you're an admin. And so we had seen cases where endpoints were not properly checking whether the user who was requesting access to that endpoint had the proper permission to access it. And there was nothing that was exactly what we wanted to kind of address this issue at a high level. So we developed a tool to automate permissions checks to kind of mitigate this broadly in addition to the individual fixes. How does this tool work? It's fairly simple. So when you know what the expected response for a request can be, you can check whether an API endpoint is working as properly. So these two examples, or these two requests, are made by a non-admin user. If they're saying, hey, get my account, and we get a 200 OK, that seems expected because every user should be able to access their own account. But if they try to access the admin portal, they should get something that says, hey, you're not authorized to access this since you're not an admin. If we see a case where we have a non-admin user or some user without the proper permissions and they're able to make a request to an endpoint and we see a response that's not what we expect, like a 200 OK here, then we know that that something is wrong. And so my coworker Sean worked to create this tool, which it's called Generator. And what it does is it takes an OpenAPI spec and builds HTTP requests so that you can try a bunch of different requests really easily. We had data about what permissions we expected to see on what endpoints. So we used this tool to generate hundreds of different requests and then compare the responses that we saw with our expected responses. And we tried this with a lot of different permissions so that we can kind of test en masse the different endpoints. And so using this tool, we were able to identify additional issues beyond what had been reported to us through our external researchers. And in addition to fixing those issues, we met with the team who owned that API, and they're in the process of integrating the automated permissions checks so that if there are any changes in the future, they should be caught automatically. It is open source, so if you're interested in looking at it and playing around, you can scan that code or just go to that link there. So before I close out, I'm going to talk about some of the most helpful learning resources for me. If I was new to security, these are what I wish I would have known about, whether learning about web vulnerabilities or bug bounty as well specifically. Personally, Web Security Academy is my favorite learning resource. It's produced by Portswigger, who creates the web security application Burp Suite, which is a really helpful tool for hackers. It has really helpful explanations for all of the most common types of web vulnerabilities that you'll see. So everything you've seen in this presentation and more, they've got really great examples of what it is. They're where I took the illustrations for a lot of those bugs. But my favorite thing about them is that they have labs that you can practice every type of vulnerability you learn about. So if you learn about access control, they'll spin up a vulnerable web server, and you can go there and test it out yourself, see how it works in practice. It's free as well. It's a really amazing resource. Second, OWASP, which is short for the Open Web Application Security Project. They're a nonprofit foundation that works to improve the security of software. I mentioned the OWASP Top 10 a little earlier, which is kind of a broad guide to the most critical web security issues seen across the industry. And one of my favorite things about OWASP is their cheat sheet series, where they go into a lot of detail about how to mitigate common issues. So if Web Security Academy is my favorite place to learn about how to find and exploit issues, I think the OAuth cheat sheet is probably my favorite place to learn how to fix those. Online courses can be really helpful. There are a lot of great courses across YouTube, LinkedIn Learning, Pluralsight, anywhere, anything you're interested you can find. There's probably free and paid courses. A lot of the free ones are really good. And finally, community. So here, SAINTCON, it's a great place to learn. This is, I still consider myself fairly new to security, and I found people are really willing to help, to teach. And places like this is a great, places like SAINTCON is a great place to do that. So if you decide that you want to learn about bug bounty, learn about web vulnerabilities, and you find a bug in a Microsoft product, please partner with us, become a bug hunter, and you can report it to us through our security portal here. I'll also note we are hiring. If this stuff is interesting to you, you're interested in looking at bugs and thinking about ways to mitigate, we are hiring 2 senior positions. It is remote friendly, so I'm the only one of my team based in Utah. We have people all across the US. We even have a few people internationally. You can apply either by going to careers.microsoft.com and searching for this job ID here, or I've linked with the QR code here. So I'll close off a big thank you, and I'll be up here if anybody has any questions or wants to talk. So thank you.